Hello guys, how are you doing? I'm just gonna check that my audio is working properly. I have battery here and I'm feeling nice. I'm gonna check my audio here. So it's good. I just took a shower, guys, and now I'm gonna continue. Now on the right screen, and now it's gonna be our last stream of the day, possibly. So then we have some business meetings, and then we have to do some coding for our company. All right, so let's go.
Congrats on making it this far. We'll now explore performance tuning strategies for upserting to pinecone indexes. To help manage requests to the API, which maintains fair use for all users, pinecone places limits on the rate and size of upsertion requests. These limits differ depending on the account type, but for some use cases, strategies have to be implemented to work around these limitations. In this video, we'll discuss batching, which involves breaking large numbers of vectors into more manageable batches or chunks. To start, we'll create a chunks function that will break our long list of vectors into smaller chunks containing batch size vectors, 100 by default. The first step is to convert the list, which is an iterable, into an iterator with the iter function. Recall that iterables are data types like strings, lists, and dictionaries, where elements can be extracted one at a time. Iterators only produce elements on demand, and return data in streams, which we need for our case. Next, we create the first chunk by calling itertools.islice on the iterator and specifying the batch size parameter. We also wrap it in a tuple. We use a while loop that continues until there are no chunks left, yield the current chunk, which can then be upserted, and then update the chunk with the next batch of vectors.
Yes, okay.
Using the same code that we used to find the first chunk. We'll first look at doing a batched upsursion sequentially, which involves splitting requests into chunks and sending them one by one to the index. We initialize our client and connect to the index. Then, we use our chunks function to create an iterator and iterate over it, upserting each chunk of vectors until every chunk has been upserted. This solves the problem of rate and size limiting, but does come at the cost of speed. This can be really slow. To speed up batch upsursion, parallelizing requests is usually the best option. In parallel batching, many batches can be sent at the same time, or in parallel. To enable parallel requests, initialize the pinecone client with the pool threads parameter, which sets the maximum number of simultaneous requests. Next, we start a with statement to connect to the index, again specifying the pool threads parameter. We begin the upsursion, which we do asynchronously so that requests can be sent independently. This is indicated with the async rec parameter, which is set to true in this case. The rest of the code is a list comprehension that upserts each chunk created by our chunks function. And assigns the asynchronous results to an object.
So that's a single line. So, okay, for chunking chunks, it's gonna create, and then it's gonna be an async request. So it's gonna do all of them in parallel.
Finally, we call the get method on each.
But in this absurd, I'm just upserting the vectors.
Asynchronous result to wait for and retrieve the responses. Although there's quite a bit of extra code here, batching in parallel can provide huge speed boosts. Time to begin batching.
Okay, let's do something better because I need a deeper explanation. With pine, okay, with pinecone, how can we do batching in sequence and parallel? time is painfully low. Here's how both work with the Python SDK. So here's the vectors. So I'm going to create, so the embeddings are the vectorized version of the values. So here I have all of the vectors. But see here I am updating the as of the vector. So here's what is defining, because I was thinking that it's giving is we're doing the vectors by its own, but it's all right. Okay. So I'm doing the batching in the. All right. So I am doing. So this yield is returning the value from I. It's gonna be from 0 to the. So here's gonna return me. The whole length of the vectors is 100, so it's gonna return me the the initial index of each batch, and I'm gonna yield the subset of that batch, a subset of those vectors, and I'm gonna do the upsert of those in here. Yeah, so this is the sequential impulse simple. Okay, and then you have the parallel one, which is for large volume using multiple batches concurrently via pulse thread. So here is the same function as before. It's gonna return me just like parts of it, and then I'm gonna observe. But so it's basically the same, but here I'm getting the error that get for erroring async results. I get the results here. Each observer returns immediately with a feature like object, which in JavaScript promises. Sorry, but I'm just thinking about JavaScript because I was mainly from JavaScript world. Sequential is fine for small jobs, a few thousand vectors, incremental updates, or when you want. I think in the hundreds of thousands of vectors to watch, don't respond no more. All right, so I got it. First, we need to make this function for chunking. So now So now we're gonna make here, and it's gonna be function definition. It's gonna be chunk function definition. So in this 14 we need to copy this in here. Okay, now I'm gonna stop showing this data camp, but now we're gonna go into Visual Studio. I'm gonna clear here, and then in the example function to break an iterable chunk, to convert the iterable into iterator. So it should be it into okay, I'm gonna ask it how to convert iterable into iterator. I need to do iter, and then in order to chunks into the here's define the batch size, which is gonna be 100. So I'm gonna be sending this 100 by 100. Well, I'm gonna I think I should do like batched, and but okay, so I need to finish. So I don't understand why I need to put like tuple. A lazy iterator over. Okay, so how to auto complete this. I should use iSlice the same as here. So I should here yield the chunk. But I need a better explanation of what does iSlice does. iterator slice. So okay, so first I'm converting to an iterator, and then this is converting an iterator into an list slicing. So, but if it's doing that, like, okay, so this is, but why is it, do I need to call tuple? This is also interesting. A promise to fetch them. Lazy iterate on tuple actually pulls the items out and stores them. Will live forever. So the tuple, what it does, actually pulls the item. Okay. Okay. So I think I'll need to recover a lot of the Python strict tools, because these are already more advanced Python, I think. Okay, but anyway, this is the way that you iterate. And I'm gonna put this into my defining a function for chunking. Now it's good. Batching upserts in chunks. So now that we have this, now we're gonna create another function. It's called, and I call 15 batching upserts chunks, and then it's gonna be like this for chunk in chunks, and here I'm gonna pass the vectors. I need to index that upsert chunk. And then print the descriptive statistics. The descriptive statistics are from here. So I should do it there. So technically this should run and make it. I'm just gonna run it in the data count first. And for that I'm going to I don't really know how many of them are we pushing right now. But with the stats, I'm gonna see it, and I'll also show you the screen of the pinecone to see how many new data points we have there. Guys, I'm really sleepy. Total vector con 1000. So it replaced the ones that were there, I guess, and I absorbed the remaining until it reached to 1000. Okay, it's good. And I guess okay, so now I'm gonna ask this to cloud to define some vectors on this file so we can run the function independently. So it's gonna autocomplete the code, so we can do the same, but to run it in my local. I also want to check that I can upsert in batches in my local machine. This is super tiring, guys. I think I don't know. I might do the batches in parallel and then go to sleep. I'm too tired. No, here. So here is not batched, it is a slice. Yeah. Yeah. So I'm defining 250 from 1 to 150. From 0 to 249, I guess. $15. And then, okay, now we need to do the same but in parallel. So we'll do this 16, it will be 16 batching upserts parallel. So in here we do basically the same. So we use still the same functions to iterate, but in this case we need to put. I'm gonna copy it here. So we still have this definition of function called chunks, and I'm gonna still have the vectors, and I'm gonna have still data camp index, but in this case I'm gonna put this here. And there we need to define allow 20 simultaneous requests and in batches of 200 vectors. So the batch size would be 200. Yeah, the vectors here I should do poll threads, it's equals to 20 simultaneous requests, so it's 20 here. I think rec is equal to true, and here should be index.absurd, and then I guess I should print the metrics, so I should copy the same as here. Yep, and then I need to I can copy this into data camp to see how does it works. In data camp is missing the key, so I'm gonna put the key, and I should also define the poll threads there. So in our case, because of the fact that I'm gonna do the read threads, because of the fact that we do this, I think we need to define the other one, which is gonna be basically the same, but this is going to be with this poll threads. It's equals to 20, and then when I save this and I import this from here, then I don't need to do this PC index, but it's gonna be PC with threads, and then I can run it properly. So if I run the number 16 here, well, I didn't. It worked, but the only thing is that the total vector count didn't change because I made this range. Okay, and now we go to the multi-tenancy and namespaces. Okay, guys, I'm gonna take a small break. I've been studying the whole day. Hopefully, I'll finish this today. So, thank you. I'll come back in a second.